Hello, welcome. Today we're going to be calculating distances along great circles. This is the first calculation part in the longitude and latitude lesson that we started. So let's look at this problem and see the way we can solve it. So if you have a problem like this in JAM or WAEC, the positions of Accra in Ghana and Lagos in Nigeria to the nearest degree are 0 degree north, that is the latitude, and 9 degree east, and 0 degree north and 32 degree east, that is the latitude and the longitude, respectively. Calculate their distance apart along the equator. Very, very important. Whenever you're calculating for distances along great circle, it has to be either along the equator or along the meridians. So note, latitude 0 degree north is the equator. So whenever you get latitude 0, it's always the equator. And that is what was given here, equator, and is also given here. So whenever you're told to calculate distance between 2 points on the Earth's surface, you check the one that is consistent. You see that the latitudes are the same. That means that this is done, the 2 points are on the same latitude. You can see the 2 points, L and K, the distance between here and here. That is what you are told to calculate. 2 of them are on the same latitude, which is 0 degrees north. But their longitudes, if you take a circle here, take another one here, you see that their longitudes are different. So you're told to calculate this. Now, if you're given this problem, don't go confusing yourself. Just check the ones that are different. You see the longitude here is different from the one here. So you just consider these two things. If it is east-east, add up the two longitudes. But if this one is east and this one is west, no, if it is east-east, subtract. Or if it is west-west, subtract. But if this one is east and this one is west, add them up. So in this case, you have the latitude for this one east, this one east. So simply subtract because they are the same thing. You understand? So we have 32 minus 9, 23. So anything you get, just do that thing all over 360 times 2 pi r. The answer is the distance between the two. Now, had it been we have 39 west, this one is west and this one is east, you have to add the two of them. So anything you get from adding the two of them, put that thing all over 360 times 2 pi r. It becomes the answer. So you see that this is very simple. You don't need to suffer yourself much. Just look at the positions of the two places that you are given, Accra and Lagos. The one that is constant is the gray circle that you're calculating across. Then check the one that is different. If the position, if it is east-east, subtract. If it is west-west, subtract. But if you have east-west, add. If you have west-east, also add. And this is for across the equator. Let's say you have another calculation and you have points. You have points A and points B, and you're told to calculate the distance between these 2 points. How do you do it? So if you have here 30 north and here 45 south, how do you do it? The same thing you do here, but since you have north and south, they are not the same, so you have to do what? Add. So you have to have 30 plus 45. Anything you get all over 360 times 2 pi r. The same thing. So just check whether you are calculating across the equator or across the meridians. It's just the same simple answer. Anything you get, the difference in the angles, all over 360 times 2 pi r. Very simple. And note that your r is always 6,400. That is the radius of the Earth. 6,400 kilometers. That is your big R. Pi is always 22/7. So that is how you go about the calculation. Anything you get as the difference in angle all over 360 times 2 pi r. That is the formula for calculating the distance along great circles, whether it is across the equator or whether it is along the equator or along the meridians, So whenever you're given a question like this, just look at the positions. If this is the same, east, subtract. If it is west, subtract. If it is east and west, add. If it is west and east, add. The same thing if you're considering it. Had it been you came here and you saw 9 here and also 9 here. Now you now have here 31 and here you have 12. What are you supposed to do? You're supposed to forget about this because this is the same as this. They are constant. That means you're calculating along the meridian. So this is what you're considering. And 2 of them are not. So what do? You subtract. It will be 31 minus 12 all over 360 times 2 pi r. But had it been you have 12 south, like you have here, 12 south and 31 north, you have 31 plus 12 all over 360 times 2 pi r. So that is how you go about solving for distances along great circles. So once you see your question, look at it very well, analyze it before you solve that. Now, why did we have to subtract in order to get 23? Now, if you look at this question now, this is the initial diagram that is given. Now, it is being calculated along the equator. So this equator is a circle on its own, and that is the circle that I brought out here. Now, from the middle, you have point K, from the middle, point K, from the middle, point L, from the middle, point L, from the middle, point G, from the middle, point G. So this circle is actually the circle of the equator, actually. So I brought it out to be clearer. Now, you're given that the first one, GK, is 32, which is this one. Oh, I've already cleaned this up. I had 0 here and 0 here. So just note I have 32 and 9. So from here to here is 32 degrees. Whereas from here to here is just 9. So what will be this remaining place? You see that it's going to be 32 minus 9. And that's why we have 32 minus 9 here to have 23. So the 23 all over 360 times 2 pi r, solving down, gives me this kilometer. So this is the distance. If I approximate to 2 significant figures, I get this. So very, very important. What you're going to go home with in today's lecture is that once you're given a problem on distances along great circle, just get to know the difference in the angle. Check the angle where you have the difference. If they are the same direction, you subtract. If they are different directions, you add. So any difference in the angle all over 360 times 2 pi r gives you where r here is equal to 6,400. So that is how we go about this. Please, if you like this video, hit the subscribe button by the side of the screen. If you have any questions and concerns, drop them in the comment section. If you want to contact us, check out the description part of this video. Thank you. God bless you.